Hi, my name is Michel. I'd like to show you a few simulations showing the effects of TeamFlow. I'm going to run a simulation right now and it will be easily understandable. So in this scenario, there's a single developer working on stories, and every story takes exactly 1 day to complete. The measurements we're taking are in blue, the throughput, which is typically called velocity in Scrum. And throughput is the number of stories we finish per unit of time, in this case, per day. Cycle time is how long it takes for one story to start from start to finish. And work in progress is just the amount of stories in flight, so between backlog and done. And none of those numbers are one. We deliver one story per day. Each story takes 1 day to finish, and the work in progress at any given time is 1. So this is a very easy simulation. There you go. Now we're going to change the simulation slightly by saying a story doesn't take 1 day to work on, but on average 1 day. So as you can see, there's like something happening in the graph. You see velocity, so throughput, and cycle time moving in opposite directions. And they kind of mirror around 1 at this moment. And this is a clear illustration of a law called Little's law. This law states that in a stable system, throughput times cycle time will be the average work in progress. And this is why these numbers, throughput and cycle time, mirror around 1. Now, they mirror around 1 because we only have one person working on each story. Once there's 2 people or there's more handovers, things will change, and that will be the next simulation. Right now, so one person is working on everything. We'll be adding a testing phase, which also takes 1 day to finish. So in the top left, we define the work, which is 1 day of development, 1 day of QA for each story, and the workers, which are the people working on things, and there's 1 developer and 1 QA person. And we'll be running the simulation again. So keep in mind that each story has only 2 days of work. So we would expect cycle time to be 2 days, right? But it won't be so. Why? Because there's a queue appearing between development and QA. And the reason is simple. As long as QA works faster than development, the queue will empty almost instantly, and everything will run smoothly. Once development starts going faster than QA, its work will accumulate in this middle queue. And that is what is happening right now. So we have a peak of 10 and 12 work in progress, stories in progress right now. And so in the graph, you kind of see this yellow line pulling at the red line, pulling it up. And when the yellow goes down a bit, the red line will go down also. Right? So keep in mind, each story had 2 days of work, but the average cycle time is 7, which means that if during this moment I would have added a story, it would have taken 7 days to reach the done state, not 2. And the throughput was kind of lower than expected. So we would expect about 1, but it's 0.85 because of this queuing time. Right. So this was just a warm-up to learn how this simulation works. Now we're going to do simulations that are more interesting. So now we're introducing UX work upstream, then 2 days of development, so 2 days of UX, 2 days of development, and 2 days of QA, and to see what happens when we do this. So there is 1 person working on UX, 1 person working on development, and 1 on QA. And we always have an average distribution. Let's run this. So I've accelerated the simulation because otherwise some patterns won't be visible. So as in the previous simulation, queues appear between each work column. UX, development, and QA spent 2 days on average for each story. But as you can see, throughput is 0.45 stories per day, and cycle time now is 17 days. So again, I start on something new. On average, this thing will be finished in 17 days, although there's only 6 days of work in it. Now we're going to change the distribution of the workload. UX only has 1 day of work and development has 3. So each story still has 6 days of work in it, but the distribution is different. So we expect a queue appearing before development. And that's exactly what happens here. So you can probably not see it, but the queue is very, very, very long before development. And what happens here is UX is done already. So UX has moved on to another project. There's no work anymore, and it has to be busy, right? So if anything changes right now in the project, UX cannot do anything about it anymore. We'll have to work in another way or hire someone new or take him back, and it's going to be a pain to do that. Just working like that in the ideal state that nothing changes, our throughput went down, but the cycle time went through the roof. We are about 200 days before from start to finish for every single item on average. So as you can see here, the latest ones had like almost 400 days before they were done. And the whole thing was finished in 630 days, 20 days, 620 days. So at this point, what is a reflex? We have a bottleneck at development. Let's add a developer, right? So let's add that to the simulation. We add a second person in development and we run it again. So we kind of see throughput going back to the initial state. So the original simulation had a throughput about 0.45, and now we have 0.45 again, but at the additional cost of an extra developer. Now cycle time seems to be much worse than the original simulation. Yep, it's 100. It's better than the previous one, so it's halved, but the original one was 17 days and now it's still 100 days. Of course, we could say, let's add a developer, but people who have noticed what happened have seen that this will not help at all. So adding a third developer doesn't change anything because there's not enough work for development. The queue has moved to QA. You can probably see it if I scroll down a bit. There you go. So this was not a good idea. We had more costs now, so we have to pay 5 people in the team, and there's no improvement. So I want to experiment with something different. We go back to the original team, where there's a UXer, there's a developer, and there's a QAer, but we're going to limit the amount of work you're allowed to do. So once there's 10 things in progress, you're not allowed to start an 11th one. And this is what we're seeing right now. So the queue here is limited. And what happens is UX has nothing to do, they just wait. So they're working about 35-36% of the time. And QA has the same problem, but that's because of starvation. There's not work enough in their inbox, in their column. And so they have to wait for work. But the velocity hasn't changed. So we're limited work in progress to 10. People start having not enough work unless you're part of the bottleneck, which is development. But the cycle time improved tremendously. It went from the original simulation where it was 200 in this imbalance simulation, and now it's 30. So an immense improvement. And the velocity is unaffected. So there is no problem by limiting work in progress. You just have a better feedback loop on the work you're doing. So let's lower the WIP limit and see if it improves things. And again, velocity or throughput has lowered a bit, but that might be the randomness of the simulation. There you go. So it's almost the same. But cycle time is again halved, which means that the cycle time, the feedback loop is now 15 days from starting on something until it's done and you get actual feedback from your customer. We'll let this one run just a bit more. And we'll be finished about 650 days. So this is the average throughput of 0.31. So now we're noticing that UX and QA are like doing nothing. And let's focus on QA, which is the last part of the simulation. And let's say that when they have nothing to do, they go to development and ask, can I help? Can I also develop? Or can I learn this skill? And this is called swarming. There's a bottleneck. Someone has nothing to do because the bottleneck is working full speed, and they go and help the bottleneck. And so this QA person is going to improve its skill. And they're going to learn development, might be Java, JavaScript, C#, whatever it is. And at a certain time, they will be able to work as a developer. And because they're a QAer, they will be able to do QA too. So let's call it full stack developer. And the QA person, I'm going to change it to full stack. And right now, when they have nothing to do, they will go and help development. So as you can see now, throughput, velocity, is kind of improving. And the development column sometimes has two stories at the same time, which is the moment that the QAer is helping development. And so you see that velocity is improving, cycle time went even more down, but the work in progress is still limited at 5. Notice that we finished the project much earlier by this slight change in velocity, 0.38 compared to 31. We now finished in about 520 days, which is the effect of having a better velocity. Now let's apply this idea of swarming to everyone. And so our developer is now a full stack developer and can initially help with UX. And the UX guy can also work on the whole stack. What happens when we do this? At this moment, we limited work in progress to 5, but it's not needed because there's always exactly 3 items in progress. And look at the velocity, which is way better than when we added the second developer or a third developer. And the cycle time is like even better than what's the ideal. Because don't forget, every story on average has 6 days of work. But every story on average is finished in 5 days, 0.9. This is probably due to the randomness of the simulation, which is maybe a bit cute that stories have less work than 6 days, but it's about right. So this state of having only full stack developers in your team that can do everything is probably an ideal state that you will never reach. But what you can do is start by limiting your work in progress and to a number that is acceptable, 10, 5, depending, to experiment with that. As long as you don't go too low, it will not affect your velocity. Once someone has nothing to do because of the work in progress limit, have them help the bottleneck that has work right now, and their skill will improve, and you will go in the direction of full stack developers. You will probably never reach it, but people will be happier by learning new skills. Well, some people will be happier, some people don't like that. And that's okay too, so that's not a problem. Please notice that Little's law is always applicable in these simulations. So take the throughput and multiply it by the cycle time, and you will reach the average work in progress. If you want to play with this, it's available on github.io. You can also play with the code base, which is here. I sometimes put some work in it. Play with it, give me feedback. I always accept pull requests, and thank you for listening.